copy, only with an N or a beginning location.
You said up there we instantiated Word.
We instantiate Word here.
How come we're not using the new?
Well, behind the scenes,
'Cause of
the
the
string
string?
class does that for us.
Okay.
Okay? So we get to avoid this messy business of having to say new char square brackets and then +1 for the appropriate length. Right? We avoid all of that, and we don't actually. The computer doesn't actually avoid it, but as programmers, we get to use the tool that does what we've already done behind the scenes.
So it's just kind of built in.
It's
Then.
still got a new there. It's guaranteed that you're going to see a new behind the scenes if you went to the class and looked at how it was defined. Okay. Now, who defined this
String.
string? Who defined it? Was it God-given?
Microsoft.
Microsoft. Okay, so now if I go over to the Intel C++ compiler, or I go to somebody else's compiler, will I have the same functionality? Not guaranteed. Not guaranteed. Even though it says namespace STD. STD, standard, is not universally standard. Oh my gosh, heaven forbid. So it's standard according to Microsoft, or standard according to somebody else who vends C++. If you look at a Unix environment, the GCC compiler will not guarantee to have that functionality or the same functionality. Is that clear? Libraries for string length and string copy and string compare and so on have been around long enough that everybody does them the same way. It's a standard, it is universal because it's been around a long time. This is fairly universal as well. We can predict that most compilers will do the same functionality, do it the same way, but it's up to the vendor to make the spec. Is that clear? All right. This one, instantiating string 1, string 2, and string 3. The string class has a member function, erase, taking 2 parameters. That member function takes 2 parameters. Starting, again, you have to read how does erase work? So you have to read the documentation on what do these parameters mean. Starting at 0 through 7, get rid of those, the first 7. Replace, starting at 9 for 5 with whatever is in S2. And insert, starting at 0, this whatever is in S3. And erase, and then there's some argument here, the result of another size operation, or append, or find. And the list goes on. What's important for you right now is to look at the notation here. The name of the object dot the name of the member function. And then member functions can take 0 or more parameters. Now there may well be 2 erase functions, one of which takes 1 parameter and the other of which takes 2 parameters. They will be different erase functions in reality, but they will both be called erase. We're overloading the erase function. Is that clear? Make sense? In point of fact, up here, string S1 invokes something we call a constructor. A constructor. So the constructor is a piece of code that runs behind the scenes that runs behind the scenes and is guaranteed, automatic, it always has to be there for any class. If you don't specify what the constructor does, C++ guarantees it will do something to construct that object. In this case, the constructor runs for one argument, and that's a char star is the argument, right? A char star constant, and will allocate enough space to hold this. Now we could have, and you will, for the fraction class, develop more than one argument for a constructor. So you'll have a single argument constructor, you'll have a two argument constructor, okay? So we could, if we had another constructor here, we might conceivably say string 2 or string dot 2, I'll get it right, string dot s2 left parent lord comma 4. I don't know what the 4 means. It might mean that's how many instances of that I want, or it might mean that's how long I want it, or it might mean something else. It's a parameter that's given to the constructor when it is instantiating S2. Is that clear? All right. String compare operations. A name, username, and we input some stuff. This is equal, isn't it? I can't even read that up here. Kelvin, you can read it? Let's see if I can make that a little bit bigger.
Wow.
I can read it now. Okay, so this says if username equal a name, we'd expect that. We kind of intuitively know what that means and what it does. Here's another, username.compare. What kind of comparison do you want to do? What kind? Where do you want to compare? 0 and 2, starting for length. Here's what I want to compare to, starting for length. I could well envision writing a compare that also has a parameter. Do you want to compare the bit patterns in each of those? Or do you want to compare the length? Or do you want to compare addresses? There's a whole variety. In fact, Visual Basic supports a long list of types of comparisons that we could do as parameters on a compare member function of this object. Let me ask you a question about terminology now. Username is an object. What is the class? It's only what we've been talking about for 20 minutes now. What's the class? String. Okay. Username is an instantiation. It is an object of class string. Okay. Here's another one. Substring. A member function of the string class looking for and returning the substring of a name starting at 0 for length of 2. Things that we might like to have. String find. S1.find. Find that string, pattern match, search for in this, which is S1. Find that string in there and return the offset of the first character that matches in that word. So, Kubla, is it there? No. Keep moving down there, it'll give me that address. Find first of. Choose any one of those, SPDE, and return to me where it is in the string S1. Is that clear? Where it does, pick them off, just kind of like string token. Kind of like string token. Not anything we haven't thought about or seen before. First not of. First not of. So we're looking for consonants, right? These are all the vowels, upper and lower case, and where's the first occurrence of the first consonant? Okay. Just some examples. I think we already looked at this one. Now we're going to look at, all right, we have the ability to use a class, we've seen that, string class, but we didn't see anything about how to write it. Where did we define the class string? Well, we're not going to do the class string just today because it's fairly involved and you'll do that next term. But here's a simple one for array class. We're going to define an array class. Remember, I've said many times that in C, we have to be careful not to run off the bounds of our array, right? C doesn't provide any support for saying you're out of bounds, you stepped off the end of the array. So we can, through the magic of object-oriented programming and defining a class, we can do that checking ourselves and then use the safe array class from that point on. So the object is SA1. The class name is safe array. Safe array. Safe array says, okay, I want you to put an element into safe array, into SA1, into that object. I want to put in the jth element, I want to put j times 10. Stuff it in there. That is an example of a setter. Sometimes, way back when, we used to call them putters, but in any event, setters set values into the object for us. Okay? Getters are getL here, give me, return for me, the jth element of that array. Okay? Now, we're talking about safe arrays. We know that there's a limit here on this. That would keep us from going beyond the boundary. But what about if I try to sneak it in and do otherwise? Will my class keep me from referencing something outside the limit? Limit here is a pound define, I believe, or maybe it's a constant. It's a constant of 100. And here's the class called safe array. It's the class that we have instantiated in main, but it's not part of main, is it? Has a reserved word class, and it has some components, and it ends in a semicolon. Okay? So the class, here are the elements. Private to the class, we mean only member functions can then get direct access to things that are in here, things that are in the private parts of the class. So array of size of 100 is only accessible directly, only settable, getting and putting only through member functions. Now the member functions are all public. They're all public. So we can, as a consumer, get access to them. In other words, if I tried to say something like SA1 sub 2 equals 4, I would get a compilation error, right? All I want to do is to set a 4 into subscript 2 of my array. Well, maybe the array name was wrong. Well, let's call it ARR. Let's make that better. Maybe that's where my error came from. Still an error. Why? Because in the class, in the object, which is the instantiation of the class, that array is private. Okay? I can only get to it via these public member functions. Okay? Now, if, heaven forbid, I changed this and made it public. Okay, public colon. So ARR is now a public member, right? A public member of the class. I could then come down here and this statement would be perfectly legal. No problem. But then I really would be writing overhead stuff. I'd be writing the whole class for absolutely no reason, right? Because I've just taken the shrink wrap off of my class and said anybody can get to it. Clear? All right, so back up here.